Section 2.4, Formulas. A formula is an equation that can be used to calculate an unknown quantity by using known values of other quantities. Formulas also establish a relationship between different quantities. In this section, we're going to see how we can use some formulas to help us answer some problems in geometry, and also how we can take a formula and literally solve it for one of the variables that's present in the formula. So, some geometry. Here we are asked to find the perimeter and area of the region below. We have a rectangle, and so hopefully you are aware that the perimeter of a rectangle is given by twice the length plus twice the width. Now, if you forget this formula, remember for most shapes, the perimeter is you just add up all of the sides. Since there are two lengths and two widths in a rectangle, we can simplify that formula. So the perimeter then would be 2 by 4 yards plus 2 by 2.5 yards, following the order of operations, would give us 8 plus 5, or 13 yards. The area of a rectangle is known to be its length times its width. You simply multiply the dimensions. So the area would be 4 times 2.5, or 10, and the units on area are a square units, and so we would have square yard. So 10 square yards. Here we are asked to find the area again. We are given a rectangle. I'm sorry, a triangle. The area of a triangle is known to be 1/2 of its base times its height. So the height is always at a right angle to the base. So here we have 5 feet. We can take this to be the base, and the height is this measure, 3 feet. Now, if we had seen this diagram, we usually see a diagram that's more like this. The area still is the same, 1/2 base times height. So the area is 1/2 times 5 times 3. 5 times 3 is 15, so we have half of 15, or 15 halves. And the units on this would be square feet. Of course, if you wanted a decimal number, 15 over 2 is the same as 7.5 square feet. Find the circumference and area of the region below. Here we're given a circle, and we're given that this distance across the circle is 6 inches. Now we call that distance across, we call that the diameter. the distance from the center to the edge is called the radius, and the distance all the way around, so if we start at some point, go all the way around, that distance around is called the circumference. The circumference is known to be 2 pi times the radius, 2 pi r. Now, it is known that the radius is half of the diameter. Radius is half of the diameter. So the radius then would be 1/2 of 6. The radius would be 3 inches. So if the circumference is 2 pi times the radius, then we would have 2 pi times 3, or 6 pi inches. Now, if we wanted, so that this would be an exact value, if we wanted an approximation, we would have to know that pi is approximately 3.14. And so we could multiply that by 6. Bring in the decimal. So approximately 18.84 inches. We're also asked to find the area. The area is known to be pi times the square of the radius. So the area would be pi, and the radius was 3, so 3 squared, pi times 9, or 9 pi. And again, if we wanted to multiply that out to get an approximation, so that would be approximately 28.26, and the units would be square inches, because it is an area, and areas have square units. We're asked to find the area of the region below, and here we are given a shape that's called a trapezoid. And a trapezoid has 2 parallel sides and a height. So these 2 parallel sides are called the bases. So I will call this B1 for base 1, and B2 for base 2, and we'll call this the height, H. It is known that the area of a trapezoid is given as 1/2 quantity B1 plus B2 times H. So basically what you do is you add the bases and divide by 2. You basically find the average of the bases and multiply by the height. So the area would be 1/2 of 6, I guess I call the other one 1/2 of 10 plus 6 by 4, 1/2 of 16 by 4, 8 times 4, 32, and the units on this would be square feet. Angles in a triangle. We're asked to find the measure of the third angle in the triangle. It is known that the sum of the angles in a triangle is 180 degrees. So basically, angle 1 plus angle 2 plus angle 3 must add up to 180 degrees. Well, 57 plus 68 plus angle 3, let me call that x, is 180 degrees. And these are all degrees here. 57 plus 68 is 125. So then subtracting from both sides, subtracting the 125 degrees. X would be 55 degrees. So the measure of the third angle would have to be 55 degrees. So now a word problem dealing with the angles in a triangle. In a triangle, the two larger angles differ by 10 degrees. The smaller angle is 50 degrees less than the largest angle. Find the measure of each angle. So we have three angles. The two larger angles differ by 10 degrees. So if I say that there's the largest, there's the middle angle, and then there's the smaller angle. The two larger angles differ by 10, and the smaller angle is 50 degrees less than the largest angle. So let me call the largest angle x. Since the largest and the middle angles differ by 10 degrees, this angle must be x minus 10. Differ by 10 degrees. It must be 10 degrees difference. We have to subtract 10. The smaller angle is 50 degrees less than the largest, so it would be x minus 50. Now I know the sum of the angles must be 180 degrees. And I'm not going to worry about the degree measure, the degree symbol right now. We just know that the sum must be 180. Combining like terms on the left, I would have 3x minus 60 is equal to 180. Adding 60 to both sides of the equation gives 3x is equal to 240. And dividing by 3, we have x is 80. So then the largest angle was x, and so that would be 80 degrees. The middle-sized angle would be x minus 10. 80 minus 10 is 70 degrees. And finally, the smaller angle would have been x minus 50, and 80 minus 50 is 30 degrees. I'll just check real quick. 80 plus 70 is 150, and 150 plus 30 is 180, so we have a reasonable answer. Determine the volume and surface area of the box. Alright, so first the volume. The volume is a measure of the three-dimensional space occupied by the box. And the volume of a box, a rectangular solid, is known to be length times width times height. So we would have 22 by 14 by 10. Let's see, 22 by 14 is 308. And so we would have 3080 And the units, three-dimensional, so it's basically we're kind of taking a third power. We'd have cubic inches. Now the surface area, basically what we would do for surface area is we would take the area, there are 6 sides to this box, and there are 2 of them. Each opposite box has the same dimensions. I shouldn't say opposite box, I should say opposite face. So for example, we have this face right here, which is 22 by 10. 22 by 10. And there's another one just like it on the opposite side. And then we have this one, which is 14 by 10, and another one like it on the opposite side. And then this one, which is 22 by 14, and that's the top, and we have one just like it on the bottom. So there is a formula for the surface area. It's 2LW plus 2LH plus 2WH. Twice the length times the width. Right? So that's just saying take one of your sides, areas, and multiply it by 2. Take another side, multiply it by 2, and take the third side and multiply it by 2. So we would have 2 by 22 by 14 plus 2 by 22 by 10 plus 2 by 14 by 10. So that's 2 by 308 plus 2 by 220 plus 2 by 140. So this is 616 plus 440 plus 280. Adding all of these up, we'd have a 6, 13, carrying a 1, 1,336, and since this is an area, we would have square inches. So that was how to use some formulas. Now we're going to look at how to take a formula and solve it for a given variable. So here we have a formula, A equals 1/2 BH, which you might now recognize as the area of a triangle. And we are asked to solve it for B. So we aren't given numbers now, but literally we want to know how, if we could get the B by itself, what would the B be equal to? Well, just like with other equations, we are allowed to add, subtract, multiply, and divide appropriately. And so what I would do first is, I'd want to get rid of this fraction. I don't like that 1/2. I could divide by 1/2, but dividing by 1/2 is the same as multiplying by 2. So I now have 2A is equal to B times H. Now the B is being multiplied by H. To remove the multiplication, we would divide. And so we would have 2A over H equals B, or, just turning it around, B equals 2A over H. Why don't you try the other one on this slide on your own? Now would be a good time to pause. All right, so here we have V equals 1/3 pi r squared h, and we're asked to solve for h. So like with the previous example, the first thing I would do is get rid of this 1/3 by multiplying by 3. So I now have 3V is equal to pi r squared h. I want to get the h by itself. I want to isolate the h. It's being multiplied by this number, pi times r squared. So all I'm going to do is divide both sides by pi r squared. So I'd have 3v over pi r squared is h, or h equals 3v over pi r squared. Solve for y. P equals 2x plus 2y. Alright, so we want to get the y by itself. What's happening to the y? It's being multiplied by 2, and it's being added to this 2x, and then we're getting p. Alright, so here we have multiple terms. When we have multiple terms, we're going to want to use some addition or subtraction. So I'm going to remove this term. I'm going to get rid of this 2x. It's not being multiplied by the 2y, it's being added. So I'll remove it by subtracting. Now p and 2x are not like terms, so I will simply write p minus 2x is now equal to 2y. The y is being multiplied by 2, dividing by 2 on both sides of the equation. P minus 2x over 2 is y, or y equals p minus 2x over 2. We could, if we wanted to, split this up into multiple terms. So we would have p over 2 minus 2x over 2. Now when we have that 2x over 2, we see those common factors that can be removed. And so we could write this as p over 2 minus x. All right, why don't you try the other one on your own? We're given the formula t equals x minus y all over 3, and we're asked to solve for x. Okay, so what's happening to x? Y is being subtracted from it, then we're dividing by 3, and the result is t. So let's undo those. Let me multiply by 3 to get rid of the division by 3. So I have 3t is x minus y. Adding y to both sides, I have 3t plus y is x, or x is 3t plus y. Here we have some that are a little bit more complicated. Notice in this one, we're asked to solve for d, but there are two terms that contain d as a factor. So what I'm going to do here is apply the distributive property backwards. AB equals C plus A times D. So notice how I've written the C plus A in quantity and it's being multiplied by D. And if you check, this is accurate. Because if I use the distributive property and multiply that D back in, I'd have C times D and A times D. So now the D is being multiplied by this number C plus A. So I'll divide by that number C plus A. Divide by that number C plus A. So then A times B over C plus A would equal D. And again, if you want to turn it around, D equals AB over C plus A. Why don't you try the other one on your own? All right, as with the previous exercise, there's more than one term that has the a in this formula. We have r equals 2ab plus 2ac plus 2bc. I see that there are two terms that contain the a. The other term does not, so let me move it to the other side of the equation by subtracting it. So I have r minus 2bc is equal to 2ab plus 2ac. Using a technique as similar to the previous exercise, let me write this as a times something. It would be a times 2b plus 2c. The left-hand side hasn't changed. And as before, I will divide by that quantity 2b plus 2c. And so that would give me a is r minus 2bc over 2b plus 2c.